Introduction. Dams are constructed primarily to impound and store a large body of water. Reservoirs can be created by enlarging a natural lake or creating one artificially, whether on the river or off-stream. Reservoir capacity depends on the height of the dam and the topography of the valley it closes. According to the International Commission on Large Dams, what is the primary purpose of most large dams? There are more than 58,000 large dams worldwide, and approximately half of them are multi-purpose. Irrigation is the primary purpose of the largest share of existing dams, followed by hydropower generation. Irrigated crops represent 40% of total of agricultural land. It is estimated that 30 to 40% of all irrigated land depends upon dams for the supply of water, especially in Africa and Asia. First reservoir filling. First reservoir filling, or impoundment, is the process of increasing the water level behind a dam until it reaches the desired operating level. The duration and rates of impoundment can vary from weeks to years, depending on the size of the reservoir, its location, the type and height of the dam, and as well as the hydrological conditions. Filling can occur naturally, diverted through water intakes and waterway systems, or through the use of pumping units. The initial filling, performed in stages, is a crucial test for the functionality and behaviour of a dam after its completion. The goal is to ensure that the dam performs according to its original design. Particular attention is paid to the stability of the bank slopes. Approximately 2/3 of all failures and half of all dam incidents occur upon first filling or during the first 5 years of reservoir operation. The first filling of a reservoir should be properly planned, controlled, and closely monitored in order to detect deficiencies, design, construction or materials, and reduce the risk of failure. Remedial measures might be needed. As a standard industry practice, the first impoundment plan should also be prepared by the owner in coordination with the contractor and construction supervisory consultant. It's useful to engage an international panel of experts during the first impoundment process. First reservoir filling. Prior to impounding, the dam and its appurtenances, spillway and outlet work, have to be completed, and the instrumentation must be in place and functional. Following documentation has to be prepared specifically for the first filling. Enhanced monitoring program, instruments available, frequencies of readings, alarm thresholds. First impoundment plan, schedule, holding points. Emergency plan, including warning levels and procedures. The process of impounding follows in general several stages. In each stage, the reservoir rise is specified up to a filling level and kept for some time, allowing the dam to adjust to the forces under the water level. Regular inspections and controls have to be performed at each stage, in particular to detect anomalies such as deformations, cracks or abnormal seepage. Monitoring results have to be interpreted and compared to expected design behaviour. Gated outlets will allow to control the filling process, and functional tests will be performed at given reservoir levels. Reservoir operation. The release and storage decisions for each reservoir at each time step are defined in the reservoir operation rules. To guide these decisions, dam operators usually follow a rule curve derived from historical data or river flows and water demands. The rule curve fixes the target reservoir level during a specific period to allow optimal operation of the reservoir to fulfill both the short and long-term water demand as well as to meet other requirements related to navigation, flood control, recreation, ecological flows downstream, and other functional objectives of the reservoir. In basins and on river stretches with cascades of dams, it's important to coordinate the operation with downstream reservoirs. How are reservoirs managed under normal conditions? Normal reservoir operation depends on the purpose of the reservoir, the inflow conditions, and the outflow requirements. For reservoirs providing water supply, the objective is to maximize the amount of water available to the domestic and industrial uses in the present and in the future. Operation of irrigation reservoirs depends on the agriculture surface, irrigation system, crop type, and are influenced by seasonality. In reservoirs with hydropower purposes, water is used to generate electricity according to power demand. In multi-purpose reservoirs, competing water users make rule curves more complex. Sometimes they conflict due to divergent requirements for water allocation. Spillways and outlets must be properly maintained, and regular tests have to be performed. In case of flooding or drought events, the operators rely on river flow forecasts, hydrographs. Flood operation. With accurate forecasting, the reservoir can be drawn down in advance to provide additional flood storage capacity. Water will then be captured in the reservoir, released downstream through the spillways and the outlets, delaying and minimizing the flood peak and consequently the damages downstream.